Hi, this is Dr. J. Vikas Paul. In this session, we'll discuss the Macaulay's method, double integration method problem for a cantilever beam subjected to point load at end. So W is the point load, L is the length of the beam, and A is the joint, left joint, and B is this point is B. Next, so here our aim is to find the deflection at B. So due to this load, there will be some deflection. So this is a deflection pattern, and this deflection YB value we need to find. YB we need to find using double integration method or Macaulay's method. So here only one span is there, therefore double integration and Macaulay's method both are same. Yeah, first of all, in this method we will take mxx equal to, the formula is m equal to I d square y by dx square. So mxx is nothing but the moment at a section. So first of all we need to take a section xx. So in this figure we have taken a section xx at a distance of x from B we have taken here. So this is x distance xx. So at this point I am finding moment. So left side I can take, right side I can take. I am taking right side. So right side W, force into perpendicular distance, W into perpendicular distance x. So right side clockwise is minus, therefore minus Wx equal to, so my mxx in the place of mxx I have substituted minus Wx equal to, this is same, Ei d square y by dx square. Let this equation be equation number 1. Now integrating this equation I will get this equation 2. And I will get a constant here, C1. Next, now this is a slope. Integrating the above equation, we will get slope equation. This is slope equation, but C1 is unknown. To find C1, we will use the boundary conditions. So what is the boundary conditions for slope? So at A, if you observe here, at A in this deflection pattern, at A there is no slope and there is no deflection. That means at A, that is at x equal to L. See here, x is this distance. So at x equal to L, that means at A, there is no deflection, no, theta is 0, and deflection is 0. So at x equal to L, theta is 0. That we need to apply. At x equal to 0, theta is 0. Theta is nothing but dy by dx. So at x equal to 0, dy by dx equal to 0. Substitute this in equation 2. Therefore, if we substitute both this in equation 2, we will get C1 value. That C1 value is minus WL square by 2. So substituting this C1 value in equation number 2, we will get slope equation. That means by substituting we will get this equation. This is nothing but your slope equation. Let it be equation number 3. This is slope equation. Now integrating this equation we will get deflection equation. So integrating the above equation number 3, we will get this equation. This equation 4. But we will get a constant. To find this constant C2, we will make use of the other boundary condition at x equal to L, y equal to 0. So at x equal, deflection is also 0. That means at A. Therefore, we will substitute x equal to L, y equal to 0 in this equation. So we will get C2. C2 I will get it as minus WL cube by 3. Next, substituting C2 value in the same deflection equation 4. C2 value here, this value here, I will get. So substituting C2 value in equation number 4, I will get this deflection equation. I will get this deflection equation. Yeah, I will get this deflection equation. So equation 5 is deflection equation. Now I need theta B and YB. That means at B there is some slope, no? There is some slope and there is some YB, theta B and YB. So to find theta B, we need to substitute x equal to 0 in slope equation, that is in equation 3. Why x equal to 0 we need to substitute? Because at B, the x is 0. See, x is the distance from B. So x is 0 at B. Therefore, substitute x equal to 0 in slope equation to get theta B. Substitute x equal to 0 in deflection equation to get YB. So x equal to 0, if I substitute in equation number 3, that is in this equation, I will substitute x equal to 0. So if I solve it, I will get theta B as WL square by 2a. Then to find YB, I will substitute x equal to 0 in deflection equation. Where is the deflection equation? Yeah, here. I will substitute x equal to 0 in this equation. I will get YB. So YB I will get as W minus WL cube by 3ei. In this way, we can find slope and deflection at B using double integration method for a cantilever beam subjected to point load. Similarly, we can find theta B and YB for a cantilever beam subjected to UDL as well as UVL. See here, the same procedure we have to do, but first of all, while calculating MXX, see the same formula. MXX we have taken here minus WX. Here we will get minus WX, but here when we take a section, here it is WX into WX is a load into X by 2. So right side clockwise minus WX into X by 2. So minus WX square by 2. Remaining procedure is same. Integrating it, we will get a dy by dx slope equation plus C1 constant. So how to find that C1? Similarly, same here, same as we done here. So at x equal to L, theta is 0. By using that, we can find C1. Substituting C1 in that same equation, we will get slope equation. Next, again integrating the slope equation, we will get deflection equation and one constant C2. How to solve C2? Using the other equation, boundary condition, x equal to L, y equal to 0. Same as we have done here, same. Using that equation, we can find C2 also. Here also, same. The value will be different. Now, substituting the C2 in the deflection equation, we will get deflection equation. Like this, we will get one deflection equation like here. So, substituting x equal to 0 in slope equation and substituting x equal to 0 in deflection equation, we will get the theta b value as WL cube by 6CA for this case, UDL case. YB as WL power 4 by 8A. Similarly, for UVL also we can do. So, for UVL, if we take cut a section here, the height of this is WX by L. WX by L is the height. How? From similar triangles. W by L is equal to L. This is total length is L. No? So W by L equal to this value divided by 6x. So from here this value we can calculate, that is Wx by L. Now, so moment at this point is half. So area of this triangle is the force into centroid distance of this part, centroid distance from this centroid of this portion, this triangle, right side triangle, and the distance, that is x by 3. That is a perpendicular distance. But what is the force? Not but area. So what is the area? Half into base x into height, Wx by L. Half into base into height, x into Wx by L. So half into x into Wx by L into x by 3. X by 3, it is the distance. So we have to apply this one. So right side clockwise, therefore minus we need to apply here, minus. Yeah, so theta b you can calculate like this, and yb also we can calculate in the same way we can calculate.